Hi, this is part 2 for the tutorial on how to convert our files for FeniCS. So in part 1, I discussed how we can convert our file to XML format, our mesh, and also boundary condition tags for complex geometries. In part 2, I'm going to address 2 additional topics. Number 1, what if we have a field variable that's an input to our PDE that we need to solve? How can we convert that to FeniCS? So a great example of that is solving transport problem, like an advection diffusion equation where your velocity vector field is already obtained from a Navier-Stokes solver. You have that data and you're now bring it into FeniCS to solve the advection diffusion equation. So how can we do that? And number 2, the XML format that I talked about in part 1 that we create is, it's great, it works, but the problem is that it doesn't support high performance computing. So you can't read or write in XML in parallel. So now that's not a big deal if you're only reading it once. So if it's just the mesh and boundary condition tags that you're only reading it once at the beginning, that's fine. You can still use that. Even if you're running an HPC code, essentially just one processor will read the file and things will still work. But the problem is that what if your mesh is huge, or what if you're constantly reading these input files? So the example of that would be velocity for solving a transport. So in that case, you want to make sure that you're supporting you're saving your files and reading them in a format that supports HPC. So the appropriate format for that is an H5 or an HDF5 file, which I'll talk about today. Okay, so now in this file that I've uploaded, we have a series of functions that give us some functionality for converting to H5 format, which is a format that supports high performance computing, so we can read and write in parallel. So then, so to use this, you'll set the inputs here. Basically, you'll define your path for your XML files. You'll define the path for your velocity. Here you have your XML file for the entire mesh that you read as input. You also have the boundary condition tags that you read as input, and you want to convert it to H5. So these XML files I showed you in the part 1 how you can create them. And then your output is written for the mesh as an H5 file. And you also have here a boundary condition tag as an H5 file. And then you have your velocities. So you have a series of velocities. So this is the index for the first velocity, the last one, and the interval between them. So something that looks like this. In my case, I have my velocities from Semascular called all underscore results, and then the different values. So you can see all the files here, and these are what I'm defining here to read. And then where I save my files, the velocity file. So they have 3 functions here that will run when you run this code. The first function converts your XML mesh to an H5 mesh, and the second one does the same thing for the boundary condition tags. So essentially, these are these 2 first functions here. Nothing fancy, pretty simple. It reads the XML file, converts it to H5. And then the last function here is for VTK to H5. So this one is this function here. It reads your velocity files in VTK format. So in my case, it's in VTU format. So I'm using VTK XML unstructured grid reader. So if you have VTK, you can just remove the XML part here, and here you can put VTK instead of VTU. So define the name of your file. And also an important thing here is that you need to specify the field name. So the field name is the field variable that's inside, that's associated with your VTK file. So in my case, it's velocity, but if it's something else, and you can see this under information in ParaView, if you load your VTK file to ParaView, you just specify the name of the field variable that you want to read and convert to H5. So we convert all files to H5, and the nice thing is that the output is just a single file. So in this case, this is the name of the velocity file. So you can see in this folder, I have all these VTU files, and I save them all into a single H5 file, which contains all the steps. And to read this out in the next tutorial that I'll talk about solving mass transport in more complex geometries, I'll show you how you can read the different time steps from this H5 file. And if you still prefer to use XML, you can use the previous part 1 of the tutorial for just creating the XML mesh and tags. And for the velocity, I'm going to also share this VTK to XML script where you can read your VTK file and convert them to XML. So you can have an XML file corresponding to each velocity VTK file you have. So in this case, the code is VTK unstructured reader and VTK. So if you have VTU, you can add XML and VTU here, similar to this H5 file.